Good afternoon. I welcome all the participants to this webinar on converting Dhalaos to transfer stations. The webinars are being organized under a project funded by UNEP Climate and Clean Air Coalition's Waste Initiative. Terry and ABT Associates come together to organize this series of webinars for city network participants as a form of continuing education for improving practices. Today's topic is extremely relevant for the Indian cities, as Dhalaos often become stinking dumps of garbage and raise fears of rodent infestation and disease outbreaks. Transfer stations will help reduce the manual handling of waste and spillage of waste during transportation. Thus, this is also being sought as a solution to the present level Dhalaos. We have today with us Mr. Robert Dick and Dr. N.B. Majumdar. Mr. Dick is the Vice President of SCS Engineers. He received a BS in Civil Engineering from Virginia Polytech Institute and State University and is a licensed professional engineer in Virginia and North Carolina. Mr. Dick has also directed and completed numerous project assignments related to solid waste planning and facility projects which have involved residential and commercial collection and recycling programs, as well as convenience centers, material recovery facility design, permitting, construction, and operations consulting. Between 2008 and 2016, he made several trips that involved conducting site reconnaissance activities at numerous open dumps and other solid waste management facilities in various cities and megacities in India. Dr. Majumdar is currently serving as Honorary DG, Sulabh International. He retired from HUDCO as Chief Projects, heading the Waste Management Cell. He has been an international consultant to WHO, ADB, and Rotary International, and has worked in various country and multi-country assignments. In India, he has worked as a consultant to Terry and Sulabh International. Dr. Majumdar has also served in several policy and technical advisory committees on waste management and renewable energy technology for the Government of India. Thank you both of you for taking your time out for this webinar. Just go over the format. We will first have a presentation from Mr. Dick and then Dr. Majumdar. We will have the questions and answers session at the end of both the presentations. I now hand it over to Mr. Dick. Thank you, sir.
Good afternoon. My name is Bob Dick, and I want to thank everyone for joining me in this webinar to discuss the conversion of Dhalaos to scientific transfer stations in India. I would like to thank my friends at Terry for allowing me to present in this webinar today. I thought that we would take an opportunity to start by defining some terminology, look at the current role of the Dhalao in the waste management system in India, talk about ideas and strategies for enhancement to make the Dhalao a more efficient feature within the waste management system and reduce environmental concerns and nuisances. Look at the role of collection centers in an integrated waste management system. Talk about the ideas and strategies for converting Dhalaos into collection centers. This assumes that you are able to acquire a little bit more space than the typical Dhalao has. And then talk about the role of scientific transfer stations in an integrated waste management system and the ideas and strategies for replacing the Dhalao with transfer stations. A Dhalao, I wanted to start with defining some terminology so we all are understanding how I'm using these terms today. A Dhalao is any form of a three-walled bay or bunker or a building structure typically constructed of concrete or block, and it's utilized for the collection and aggregation of solid waste from residential and commercial waste generators. Typically, the waste is tipped at the Dhalao manually by a municipal waste collector, cleaning staff, Safai Karamchari, and the Dhalaos are typically not equipped with any container. A collection center is a facility established for collecting solid waste and recyclable materials from residents, and in some cases, small businesses or institutions. This is a facility where individual residents can dispose of waste in bulk storage containers, and they're serviced by collection vehicles. A collection center typically does not allow commercial waste, and it does not have waste collection vehicles tipping the waste there. And finally, to define a transfer station, it's any solid waste storage or collection facility at which the solid waste is transferred from collection containers or vehicles to larger long-haul vehicles for transportation to a central solid waste management facility for disposal, incineration, or resource recovery. Typically, transfer stations don't allow for manual tipping of waste, and they're not used by individual residents or businesses. The current role of the Dhalaos in the waste management system in India: the waste collectors collect the waste door to door using carts of various shapes and sizes, and they tip onto the floor of the Dhalao. The waste is aggregated from the local neighborhoods and surrounding communities, and as you can see, the conditions at the Dhalaos involve the tipping of the solid waste directly onto the floor within the Dhalao and also in front of it for collection. The servicing of the Dhalao, a front loader and dump truck are usually required to extract the waste from the floor of the Dhalao. This is an intensive process in which it requires multiple manpower and equipment in order to pick up the solid waste from within the Dhalao and surrounding it by the front loader and placing it into the truck in order to be transported to the disposal facility. The challenges with the current role of the Dhalao are the inefficient handling of the waste multiple times. It generally has a relatively small storage capacity. The waste is not containerized. It contributes to traffic congestion and unsafe conditions during servicing. It has to be serviced frequently throughout the day as the Safai Karamchari, the waste collectors, are continuing to bring the waste to the Dhalao. There's nuisance concerns, odors, appearances, livestock and animals get into the trash, and there's the potential environmental and health concerns. So let's talk a little bit about a potential solution for enhancing the existing Dhalao structure. So if you find yourself in a situation where you are limited to utilizing your existing Dhalao and cannot expand for another type of facility, one idea is to insert a roll-off container into the Dhalao. The Dhalao comes in many different shapes and sizes. Sometimes they're covered. Most of the time they have at least 3 walls. And one idea is to install a ramp. Over here, what you see in this photo is a block wall has been used to build up the elevation on the side of this container, and you can install a ramp to enable waste collectors to tip the waste from their carts at a higher elevation into the roll-off container. And so you can use a Dhalao with the sidewalls only so that the containers can be serviced and replaced from either end. And so I feel that it's important to get the waste containerized in the Dhalao. That will make the process of servicing the Dhalao more efficient, because a roll-off truck can come and bring the container to the disposal facility and replace it with an empty container. Along this same line of strategies and solutions, you can insert an actual compactor and the associated container into the Dhalao. This requires electrical service to be provided, but it does enable a more efficient operation. In this situation, the compactor is stationary and remains permanently at the Dhalao and is compacting the waste. Here you see a picture of a typical compactor. The container is the portion to the right, and that is the portion that gets disconnected from the compactor, and the truck removes it and provides a replacement container. What you see towards the left is the actual compactor that is permanent and stationary. And in this case, this picture shows the example of a top-loading hopper, and so you need a ramp to enable the waste collector, or perhaps individual residents and businesses, to place their waste from a higher elevation. If you cannot construct some form of a ramp in order to achieve tipping into the hopper from a higher elevation, you can utilize an on-grade hopper for the compactor, so a retaining wall or any type of ramp is not necessary. I believe this improves the waste collection efficiency from an enhanced Dhalao. It eliminates multiple handling of the waste and increases storage capacity to reduce the frequency of servicing. I believe one of the primary goals is achieved is that the waste is containerized early in the process of collecting and transporting the waste to the disposal facility. Clearly, you've reduced the manpower and equipment during servicing. You no longer need a front end loader, and a single truck driver can operate the roll-off truck in order to remove and replace the containers or the roll-off bins. You reduce the traffic congestion and improve safety during the servicing, and we decrease the nuisance concerns. The Dhalao doesn't have as much aesthetic problems, and it decreases potential environmental and health concerns. So that's a situation where if you are limited on space and you have to utilize the Dhalao, you can enhance it to make these improvements. Let's talk a little bit about the role of collection centers in the integrated waste management system. Here I show an example of an aerial photo of a typical collection center. You may need approximately a quarter to a half of a hectare. That's about 1 acre in U.S. English units to construct and operate a collection center. What you're looking at here, the bottom lower part is where vehicles enter, and they're able to utilize some recycling containers for different recyclable materials. As the vehicle moves in a clockwise direction, then you come to the top of the screen where there are compactors for the solid waste and vehicles, or in the case of cities within Delhi, the waste collectors could bring the waste in the carts in order to place it at a collection center. Collection centers can handle, obviously, more quantity and throughput of solid waste than a single Dhalao. This is another example, aerial example. Again, vehicles come in from the top, and in this case, they move in a counterclockwise direction, and it shows the containers or bins for recyclable materials, and then the high walls here where you see the staggered containers for tipping from an elevated ramp. And then the service vehicles, the trucks, are able to pull the containers and replace them with empty containers without interfering from the residents or waste collectors who are tipping the waste here. So again, let's talk about ideas and strategies for converting the Dhalaos into more of a collection center type model for collecting the waste. First is to place structural fill on the outside of the Dhalao to increase the elevation and transform the Dhalao walls essentially into a high wall for tipping into the top of the roll-off containers. And here in the photos, you see examples of the roll-offs being staged or positioned against a high wall, which could be the side wall of an existing Dhalao. Again, this strategy does require the municipalities to acquire some additional space around the Dhalao, but not significant space. Again, another idea which, in order to achieve greater compaction of the waste within the container, is to utilize the compactor. Anytime that you can use a compactor, you will have greater density of the waste in the collection container, and that is more efficient for transportation, and you reduce the frequency of servicing. So an idea here is to transform the Dhalao walls into high walls for tipping the waste into a compactor hopper. And again, here in these photos, you see examples. A hopper for a compactor, it can be from a top loading position where you will need to have some sort of elevation difference, or if that is not feasible in your situation, they do make hoppers where you can install them on grade so that the waste can be easily placed without needing an elevation change. Another benefit of the collection centers model is that you can introduce containers for recyclable materials where adequate space is available. And I recognize, having observed many of these Dhalaos, oftentimes there's not substantial space. They are positioned within the urban centers of cities and megacities. But any time that you can get a container in which would allow segregation of recyclable materials, it would be beneficial to divert these materials from going to the landfill or other disposal facility. Ideally, the collection center site would measure about 1/4 to 1/2 hectare and would have electric service in order to utilize these compactors. Again, the advantages, I believe, with improving waste collection efficiency and introducing recycling with the collection center model, it's the same benefits as the enhanced Dhalao. It eliminates multiple handling of the waste, which is typically happening with the Dhalao type of structure, and it increases the storage capacity to reduce the frequency of servicing. The waste is containerized. That's important. It reduces the manpower and the equipment during the servicing, which doesn't happen as frequently. It eliminates these nuisance concerns and eliminates potential environmental and health concerns, the runoff or releases of solid waste. And actually, the collection center model, it allows for separation of recyclable materials. And finally, let's talk a little bit about the role of transfer stations in the integrated waste management system. Remember, my definition of a transfer station is typically where you're transferring waste from either small containers or actual vehicles, the collection vehicles, to larger containers and vehicles. So this is just in order to make the transportation be more efficient with the largest vehicle possible. So scientific transfer stations in India are being utilized in many communities. It's basically for the consolidation of waste for transportation to the disposal facility. Here in this picture, you see a transfer station in which the hopper and is top loading. So there's an elevation difference where the collection vehicles tip the waste into a hopper and a compactor. On the left shows the compactor container in place and connected to the hopper. And then on the right, you see the process of the roll-off truck servicing the container by removing it and transporting it to the disposal facility, and it'll be replaced with an empty container. Another type of transfer station is where the tipping of the waste actually happens within the transfer station building. This type of operation, you have push walls so that the equipment is in a front end loader or a backhoe type piece of equipment takes the waste and places it in a transfer trailer. That transfer trailer is in a tunnel at a different elevation than the collection vehicles that tip the waste onto the tipping floor. You can see that in this photo. So some of the ideas and strategies for replacing the Dhalao with a scientific transfer station in your integrated waste management system. Obviously, transfer stations require more area. The site has to be larger than the very small footprint of the typical Dhalao. And so one of the first things that you have to do with this strategy or solution is to collect the waste from residential units and businesses in containers. And here you see some examples of the containers or solid waste bins that can be utilized for collecting the waste. But really, with a transfer station, it does not accommodate the Safai Karamchari or waste collector type of collection for having individual people come and manually place their waste. So transfer stations typically don't allow for that. They're just receiving collection vehicles with either containers like in these photos, or you can collect the waste from the residential units and businesses with rear loader collection vehicles. So just to wrap up with some thoughts here on transfer station criteria, the waste throughput and storage capacity needs to be defined. Your other thoughts or criteria in the design and elements of operation of transfer stations include how the waste is going to be delivered and your traffic considerations. Remember, in transfer stations, you have both the vehicles bringing in the waste in containers or rear loaders, as well as vehicles, the larger long-haul vehicles that are exiting the facility with the waste. And that requires you to look at facility layout options. Other design criteria are, of course, the building size, the tipping floor dimensions, the loadout space, and what we call the queuing distance. Again, all to try to relieve traffic congestion. And of course, operational parameters of these facilities include safety, noise, odors, dust, and operational efficiency. Some of the structural characteristics to consider are the tipping floor, your push walls, the manner of design of the transfer trailer tunnel. Transfer stations can use a partial tunnel in which the front end loader has to reach up and place the waste into the top, or a full tunnel depth where it's more efficient for just pushing the waste into the top. And this depends on your site design, site-specific design parameters. Some of the transfer station design goals that we typically attempt to achieve include counterclockwise traffic flow, one-way traffic movements. You want to minimize your cross traffic, and you want to segregate your commercial haulers and smaller haulers that are coming with smaller loads of waste. If you can separate the large vehicles from the small early on in the facility, that works better. And then you need to accommodate for the vehicle staging, have your site amenities, and at all times be thinking about safety and efficiency. And so a typical transfer station design here, what you see is the collection vehicles with containers or the rear loaders are brought in on this path in order to tip the waste onto the tipping floor inside the transfer station. The vehicles that service the containers and remove the waste from the facility are on a separate roadway, a different path. And then you have space for the additional trailers or containers to be placed and stored on the site, and adequate parking for vehicles that are bringing the waste to it. And so with that, I thank you very much. I'll turn it over to Dr. Muzambar for his presentation. Thank you.
Good afternoon. It's a pleasure to be here. So I've tried to make it in a simple manner, although apparently it appears to be very simple. But if you have to actually do this, there is going to be a very, very difficult task. I mean, in our actual situation, because we have a lot of congestion in our cities, then road access also is a difficult issue. So let me move on with my presentation. So what I've done here, I've tried to, describe the actual situation here and what should have been as per our rules. What is the ground reality for the Dhalaos or collection center vis-a-vis the transfer station, which even now is in a very, in a very loosely termed topic as such, because we have very few properly designed so-called modern transfer stations. But there are others which are called transfer stations, but if you go there, you will find it's only a field, an open field where the thing is actually being done. So coming to my presentation, now ideally solid waste should be collected from the point of generation in 3 different streams as per our rules and taken to the respective processing, recycling or disposal site, excluding of course the construction and demolition waste. So this is as per our rule, which is called Solid Waste Management Rules 2016, which was notified by our Ministry of Environment, Forest and Climate Change last year. Now, the construction and demolition waste should also be stored separately, collected separately, and processed separately as per the C&D Waste Management Rules of 2016. In this presentation, of course, I'm not going to focus on the C&D waste, but I just mention this just to flag it that this remains an issue which needs to be taken care of. Then voluntary deposit at designated sites or drop-off sites is an additional option for certain items. So this is what should be done ideally and with respect to India, for Indian towns and cities. Now what is the reality? What actually happens at most of the places is quite different and often not efficient and desirable. So mixed waste is thrown or deposited in and around municipal bins at best or thrown inside a drain at its worst. So you can imagine if it is thrown inside a bin, we think that is the best option as such. That's the kind of scenario that we have. Now in some cities, for example Delhi, storage rooms have been constructed by the side of roads and even lanes. Such masonry structures are called Dhalao in Delhi and other North Indian cities. So that has become a very common term in this part of the country. Now, the Dhalao or intermediate neighborhood storage facility is a common feature of municipal solid waste storage and secondary collection. So this is a very, very common thing ingrained in our waste management life as such. Usually, these are masonry structures where municipal solid waste is dumped by small vehicles and even mule-back, as Bob has also described. Now, usually there is only one large opening which is used as entrance as well as exit also. And in many cases, they are very dilapidated structures. In most of them, the waste workers or the rack pickers take out the saleable items. Depending on what they deal with, they take out their share. And the remaining waste matter is picked up by the municipal vehicles and carried to the processing or disposal facility. In most of the cases, this is the dump site. In some cases, the material is taken to an intermediate transfer station, which may even be an open ground, which I was just mentioning. Thus, the Dhalao also represents a case of multiple handling of waste. Now, just to give a glimpse of the primary collection and some transfer options, very shortly and briefly. So this is how a transfer truck, a small truck, very small. This I think is a Tata, the 600 or something, the small one. So this is very much in use for primary collection. And then you can see the bags which are just jutting out or just hanged from the side, containing different recyclable items or rather saleable items. So this is how it is normally, in most of the cases, this is how the collection is done from the doorstep. And one of the transfer options is just tip it into a bin directly, which is happening here. You can see it here. So the tipping is directly into the bin. Now, of course, you would say if it is done by the roadside, a lot of dust emanates from there, which is not a good thing. This is another way of doing it. So in this, there is a contraption which lifts the bin to a height so that it can be tipped into the backside of or the back container of the refuse collector and compactor. So it goes directly into the bin and then it is taken up by the refuse compactor. Now the municipal solid waste transfer station. Now this is an intermediate place where solid waste collected by small vehicles is transferred to larger vehicles for ease of transport of large quantities through long distances. This arrangement, of course, has a potential to make the system faster as well as more economical because larger vehicles, they take more waste and the road congestion is also impacted positively. In most of our congested localities or wards, it is not possible to bring even small motorized vehicles. So therefore, from that context also, the transfer station has a role to play. So the doorstep collection is done by three-wheel vehicles or small four-wheel vehicles or even, small carts also, hand-drawn carts. These vehicles deposit waste at the transfer station. Larger vehicles and bulk carriers pick up the waste and move to longer distances. Typically, we normally try to do it for more than 15 kilometers for looking at the economic side of the project. Now, transfer stations can be of different types, as mentioned in later slides. But in India, even an open space where the waste is dumped, kept for some time, and then sent by larger vehicles is often called transfer station. And personally, I have seen possibly they are the largest. They are in the largest number. Or if you take the percentage, possibly they are the largest percentage of transfer station, just open fields. Now, normally, large modern transfer stations are designed as split-level facility, as Mr. Dick has also shown. A ramp leads the smaller vehicles up the ramp to the unloading points from where the waste is deposited into larger vehicles or bins through hoppers. Modern transfer stations are equipped with stationary compactors so that more waste can be packed in the receiving bin or vehicle. The total area required is quite large. Typically, for let's say 500 tons, one would require anywhere between 0.3 to 0.5 hectare. So that's pretty large chunk of site inside a city. And outside the city also, again, we have transport issues. So therefore, land or site remains a big constraint. And so this is a split-level modern transfer station. This is just a schematic this shows very clearly as to how it happens. So the smaller vehicles or even the very small three-wheeled carts, mechanized carts, they move up or drive up the ramp and they go up to the top level or the first floor level and then they drop the waste and the larger vehicles, which is shown on the right-hand side picture, they drive out with the filled waste. So this appears to be a simple system, but actually it's, there are issues because first of all, you have to find out so much of land. Secondly, the construction is pretty expensive because a lot of civil construction is there. Of course, here the electrical power requirement is less comparatively because that is replaced maybe by a little more of the automobile fuel, diesel in most of the cases. So the construction cost is quite high. Now another variation, this is in the Indian context. This is a compact transfer station. I have coined kind of this term, compact transfer station. Normally this is not there. Okay, so we built it. Built a system at Nagpur, in the city of Nagpur. So this compact transfer station was designed and implemented at Nagpur. And at the designated site, a transfer station of 100 ton per day capacity was required, but the available site was only 850 square meter. That's all. And at the back of it, there was a huge water reservoir, and on the other side, there was a weekly market, place for a weekly market. So this was, a very constrained kind of a site. So first of all, efforts were made to design a split-level transfer station using a concrete ramp, but the site was quite inadequate to accommodate the ramp with a certain gradient. You have to, you cannot go beyond the gradient of, let's say, even 14, 15 degrees, because then the vehicles would start slipping back. And at least two large vehicles for further carriage. So one empty would come and the other filled one would drive out. So at least there should be space for two vehicles. So this was not possible within this site. So then we had a lot of brainstorming, and finally, eventually we planned to design a single level transfer station equipped with a powerful static compactor with a large hopper and a set of sturdy compaction bins, each with capacity of about 18 cubic meters, those bins. And a conveyor was designed to carry the material from a ground level receptacle to the top of the hopper. The material sliding down the hopper was pushed inside the bin while forcefully compacting the same. These equipment are available, but this design was kind of done there. One limitation we found was the large size materials or large items. They were difficult to handle with this kind of system because the conveyor belt also had a certain width and the materials had to be there. And then it had to go into the hopper and they shoot at the bottom of the hopper. So all that kind of constrained the size of the material to be handled. Now this is the place when it was under construction. So you can see the hopper at the foreground, and then at the back is the conveyor, and at the back side is the static compactor. On the right hand side is the bin, and on the far right is the hook loader to pick up the bins. This is after it was constructed, so you can see the conveyor belt and the compactor, the static compactor and the compactor bins. These bins are very, very sturdy. Now the hook loader arm is now picking up this compacted bin filled with waste. Same thing. So it's almost it has drawn towards it. And we have two rails there, one on the right hand side on which this bin was there, and on the left hand side another empty one should have been there, but we have not put it there because I wanted to take this photograph, so it was not landed over there. Otherwise, these two bins are always there. One is getting filled and the other empty one is just parked over there. So this worked pretty well. The only limitation was that large size materials and very light materials like plastic sheets, they also come. Large sheets of plastic just jumbled. So they sometimes create difficulty on the conveyor belt also. Normal material with, let's say, a density of 0.4 to 0.6, 0.7, they behave very, very nicely. Now, the other, which Mr. Dick had also mentioned and shown, is the portable compactor. In this case, the compactor is a part of the bin. The motive force is supplied by electrical connection, and there is a loading bucket which can be lowered onto the floor or the road level. This bucket receives waste carried by wheelbarrow to small vehicles, and then the bucket is pulled up by a lever and the waste is deposited inside the bin. Now the compactor inside the bin keeps on compressing the waste, compacting the waste, and more waste is deposited. It's an ongoing process and the sequence goes on. These bins have strong steel wheels on one side so that they can be pulled up just like a roll-on, roll-off. And then a hook loader pulls up the whole bin along with the compactor and carries the same away. Now, in the city of Kolkata, a number of sets of these, they had built by the roadside garage-like structures where 4 sets of such bins were placed, and that was quite successful. That was about 6-7 years back, and since then this has picked up. This is a photograph in Delhi, so this is just being started there. So you can see the shed and the compactor bin. This actually the compactor bin. The yellow portion is the front end bin, which is lowered onto the ground, and then the small vehicles, they deposit or tip the waste in that bucket, and then the bucket, as soon as this is nearly filled, it just moves up and deposits it inside the bin, and then the compactor moves on and the bucket comes back. So this sequence goes on as such. Now, the issue of converting Dhalao to transfer station. See, normally a Dhalao is much smaller in footprint and size than a transfer station. On the one hand, some of the transfer stations have segregation facility apart from the role of shifting waste from smaller to larger vehicles also. Of course, these take a lot of space, typically from, let's say, 0.5 to 1 hectare as such. That kind of land is extremely difficult to find inside a city or even in the periphery of a city, because after all, the transfer station has to be, one has to see the logistic factors as to where to put the transfer station so that it is techno-economically viable as such. A pre-requirement of this exercise is to work out the feasibility and justification of such conversion, that is conversion of the Dhalao into the transfer station. This will depend on the area available, that is the most important thing, neighborhood population, population density, road access and width of road, and further destination of the shifted material. Because road, again, apart from the site, the road access is extremely important here. While planning such facility, and this is, I would say, very, very difficult. We have actually faced this while doing any such work. I have faced this in a number of cities. While planning such facility, dialogue with the neighborhood and interactive planning is very important for success. And this part, this thing, that is the number 2, this is extremely difficult, because to talk to people, to have a dialogue with the people and bring them to your side, to convince them that yes, this is going to improve their lot, their situation, is very, very difficult. And more so because we don't have a good history of such things. That is why it's more difficult to convince the people. Finally, the life cycle cost needs to be looked into to take the decision. And the ELB, of course, has to initiate this. And you see, every Dhalao cannot be converted into a transfer station. This work has to be done, this workout has to be done meticulously. And personally, I would feel that one should start only with, let's say, samples, 1 or 2 samples. See after the conversion as to what is the result, what is the feedback, and after that one can then step up the conversion things. And of course, if you look at the distances, that is the small vehicle distance and the large vehicle distance, onward from the transfer station, then you have to see where exactly a transfer station can be justified. So those are very important issues as such. Thank you very much.
Thank you, sir. Thank you, Mr. Dick. So that will be the end of this webinar. Thank you formally to Dr. Majumdar and to Mr. Dick for their insights on converting Dhalaos to transfer stations. Thank you to all the participants for joining in today. Thank you so much.